One of the most difficult parts about teaching the electric field is that it's invisible. You can't see it. But you can investigate it with various apparatus. In this video, I will teach you 10 activities and experiments that you can use to help make the electric field a little bit more visible. The plasma globe itself already looks like an electric field. Specifically, it's the electric field of a spherical charge in a grounded conductor. That's just the inside, but on the outside of the globe is where the real action is. You can see the electric field invisibly extends far beyond the glass when you use it to illuminate fluorescent bulbs. It truly is the strong electric field that's doing this. You see, the high electric field pulls the electrons off their nuclei in opposite directions, ionizing the gas. The electric field is radially pointed outward, which you can verify by taking a small linear tube and rotating it. Ha! It shuts off. It only works when you can establish a high voltage between the two ends. And that is one way to calculate the electric field, a difference of voltage over distance. You'll also notice that the electric field is not strong when you're far from the globe. You can see this with a neon bulb or a diode. Nope, it gets weaker with distance. You can also verify this with an oscilloscope probe. The y-axis on an oscilloscope is a voltage reading, and this reveals that the electric field of the plasma globe is changing at all times. You can verify that the voltage is decreasing as 1 over R as measured from the center of the globe. Be sure to have the ground input as far away from the plasma globe as possible, otherwise it may interfere with the measurement you're making. Now you can use the change in voltage over change in distance formula and make direct measurements on an electric field. But be careful, because your body can act as an antenna and will interfere with the results. One more thing. You can demonstrate that there is no electric field drop in a conductor. Once the bulb starts glowing, it becomes a plasma, which is a conductor, and as you pull it out, you get more and more of the conductor. This might help you discuss electric fields and circuits. The Van de Graaff generator is a must-have when teaching electrostatics and the electric field. For example, you can use it to show that the electric field is higher near pointy edges than rounder ones. You see, it is the electric field that ionizes the air and makes lightning. A pointy edge can do that easier because the electric field is higher. Notice also that these lightning rods are connected to the ground. Of course, you can also use the Van de Graaff generator to demonstrate radial electric field lines. For example, you can tape streamers on the top of the Van de Graaff and they will point radially outward. Or you can use a human. Find a long-haired human and have her stand on a milk crate for insulation. Remove all metal such as rings and glasses and zippers, and with any luck and dry weather, her hair will stand up. Another way to demonstrate electric fields with the Van de Graaff is to hang a string over the charged dome like you're going fishing. Watch as the charged string is amusingly repelled by the electric force field. But I think the most convincing way to show the electric field is with a straw cut in half and pinned to a meter stick. Now you can probe the space around the dome effectively. If you want to demonstrate the electric field of two like charges, get a second dome but do not connect it to ground. Their electric field lines will point away from each other, just like two positively charged electric fields. Take a petri dish and fill it with some cooking oil or mineral oil, and then stick 2 electrodes in it like these two. Then mix in some seeds. I like to use lettuce seeds, though many people use grass seeds. Then if you charge up the wires, you will see motion of the lettuce seeds. They will move to align themselves in the electric field. This apparatus is available for purchase from vendors, but you can make it yourself with coat hangers if you follow the instructions in the description below. It's important that the electrodes be well insulated, hence these plastic stands. By the way, my source of charge has been this fun fly stick for the positive side, and I use my finger for the negative or ground side. I used to use a Van de Graaff generator, but I find this to be much more convenient. Anyways, with this setup you can show various features of the electric field, such that it's perpendicular to conductors, and that there is no electric field inside of a conductor. See? The seeds aren't moving. It might be helpful to use a gooseneck camera or overhead projector to project the demo on the big screen so that everybody can see it and appreciate it. It's actually possible to map a real electric field using carbon paper with electrodes on its surface. What you're actually doing is mapping the voltage difference between 2 points and then graphing the voltage lines throughout. And if you can accept that electric field lines are perpendicular to voltage lines, then you can graph a real electric field in 2D. The hard part is figuring out what to use for the electrodes. You can use conductive silver ink, or, if you can get it, metallic tape. Some people even use actual bars of metal, but the silver ink seems to work the best. A reasonable voltage to set is between 12 and 20 volts. This won't shock you, but the measurements will be easy enough because the numbers are large. The result is that you get these nice voltage maps. And since the electric field is perpendicular to the equal potential lines, you can map the electric field near these conductors. Experiment and get creative with your electric fields. A real problem with this lab is that it takes a long time. You want to work to ensure a streamlined data collecting procedure, and you probably want to draw in the electrodes for your students on the graph. But the results are usually very good.